Alright, how you guys doing today? This is Mr. R, and I am bringing you a lesson on slope. First thing when we talk about slope, S-L-O-P-E, slope, we are talking about in a line. You should know or should have been dealing with at some point linear equations, and because of that you can see the slope. This slope is actually a rate of change, and the thing about it being a rate of change is it has to be two pieces. So other rates that we use, maybe miles per hour, this would be, if you're going down the interstate maybe at 65 miles per 1 hour. So a rate of change is a ratio. It's going to be a fraction, and there has to be two parts. Okay, so when we deal with this with a linear equation or a picture of a line, we're going to work with this. The two things that we're dealing with when we have a coordinate plane, we have an x-axis and a y-axis. And slope is the rate of change between the x-axis and the y-axis. So the slope is the vertical change over the horizontal change. So to review what vertical and horizontal are on our coordinate plane, vertical is this way, up and down. Horizontal is this way, left and right. Another term that you'll hear used is this is the change in y over the change in x. Meaning, how much does the y change over how much does the x change? So between 2 points. The change in y would be this way, the change in x would be that way. So whatever this change and this change in y over change in x. You're going to hear a shortcut term or phrase, rise over run. This rise means vertical, run means horizontal. This is a little shortcut to kind of remember. I'm going to use these terms the most, vertical change over horizontal change, because if you can always remember vertical is up and down and horizontal is left and right, then you're going to have a good shot at being able to figure out what the slope of a line is. Okay, let's do an example. On this first line that I have for you, this line is going to go on and on forever and ever in both directions, continuing that way and continuing that way. And between each point on the line, you're going to have a change. So if you look here, from this point to this point, the vertical change is 1. The horizontal change is 1. Again, vertical goes this way, horizontal that way. From this point to this point, vertical change is 1, horizontal change is 1. Here to here, up 1 to the right 1. Up 1 to the right 1. So between all these points and continuing on forever and ever, your points change vertically +1, horizontally +1, making this slope 1 over 1. We can always simplify our fractions too. So this slope is 1 over 1, makes this 1. Try to brighten this for you a little bit. Okay, 1 over 1. So this slope is 1. 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 1 over 1. So this slo Okay, let's look at a second example. Okay. Here again we have a line. You see that there are several points on the line. It's actually an infinite number of points on the line. But we want to choose points that are on what I call them perfect corners of our grid. So obviously I have some graph paper here. Technically, there's a point here and 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 so on and so forth going on throughout the line. But it's easiest to calculate the slope or count the slope by picking points that fall on perfect corners. This point here, for example, is not on a perfect corner and is sort of fractional or decimal. So by using these ones that are on perfect corners, it's a little easier to count the slope. So from this point to this point, the vertical change is 1. I'm sorry, 1, 2, 3, I got ahead of myself. Vertical change is 3, sorry about that. Vertical change is 3, the horizontal change is 1. From this point to this point, vertical change is 3, horizontal change is 1. And again, 3, 1. If you don't have 2 points that are next to each other, say for example, I wanted to go, what's the slope from this point here to this point here? Well, I would travel up 1, 2, 3, 4, 5, 6, and to the right, 2. So my slope between those 2 points is 6 over 2. But my slope between 2 points next to each other is 3 over 1. If you were to simplify the fraction 6 over 2, what's 6 divided by 2? 3. 3 over 1 simplifies to 3. The slope here is the same, whether you're counting 2 points next to each other or if you skip a couple points and go on. From here it would have been up 9 over 3, which would also be 3. Just having a hard time getting some good light for you here. So, as you can see, finding the slope, you can do it by counting. Another example. Be like this one here. So I have several points on this line. There's a point here, a point here, a point here, and so on and so forth. Now when I look at this line, if I could pick any 2 points on the line, let's say maybe I go from here. Now, my vertical change goes down. Okay, my change between these 2 points is -2. Okay, going this way, it's +1. Okay, if I were to go the other direction, I could say maybe from this point to this point, maybe it goes +2 to the left is -1. So here again, down 2 to the right 1. So this slope is going to come out negative because my vertical change was -2. My horizontal change was +1. -2 divided by 1 is -2. If I looked at it the other way, where my vertical change was 2, my horizontal change was -1, that's also going to simplify to be -2. 2 divided by -1 is going to be -2. Okay. Now, one quick thing I want you to look at here. Here's the example from number 1, side by side with the example from number 3 here. A positive slope positive slope is going to rise from left to right. So as we read across the page from here over, it goes maybe up, it rises. The horizontal change is positive. The vertical change is also positive. A negative slope is going to fall from left to right. It goes this way. And in this case, one of the two, either the vertical or the horizontal, is going to be negative while the other is positive. I tend to always start on the left hand and go to the right. That way you're either going up and over or down and over. It's kind of a good trick to help you with that. So that's how you count slope from a graph. I want to show you what to do if you're given 2 points. Okay? If you're given 2 points, let's say, for example, you're given the points 5, 7. This is going to be a point on the graph, and the point 3, 4. Okay? We can actually find the slope between these 2 points without going to the graph. Okay, remember what we said about the vertical change? Over the horizontal change. Okay, the vertical change is going to be the y-axis, right? These are the change in y, and these are the change in x. So look, if I do my vertical change, I'm talking about 7 and 4. Those are the 2 points on the y-axis. So I'm going to do 7 minus 4 for my vertical change. My horizontal change is going to be 5 and 3. Now, since this way I did 7 take away 4, here I'm going to do 5 take away 3. 5 take away 3. Vertical change, y. Horizontal change, x. 7 take away 3 is 3. 7 take away 4 minus 4 is 3. 5 minus 3 is 2. So the slope of the line that passes through these 2 points should be 3 over 2. Let's grab a coordinate plane here and see how that comes out. What were my 2 points? I had the point 5, 7. So on the graph, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Okay? And the point 3, 4. 1, 2, 3, 1, 2, 3, 4 is right here. Alright. Let's take my ruler, make sure we get a good straight line. Okay, here was my 2 points that we already talked about. Now, going back to what we did before, the change here from this point to this point is going to be positive 3, positive 2. So that slope would be 3 over 2, which, as you can remember, we had before on 3 over 2. Let's do another one like that to make sure that we are settling this home. Let's take the points negative 3, 5, and 1, 2. Okay, I'll do the second one. Again, I'm going to do vertical change. So, y take away y. 5 minus 2. Okay? On the bottom, I'm going to have x take away x. So remember, since I went this direction, I have to continue to go this direction. So negative 3 minus 1. This is going to give me 5 minus 2, 3. Negative 3 minus 1, negative 4. So the slope between these 2 points should be 3, negative 4. So again, what were my 2 points? I'm trying to do this quickly for you here. Negative 3, 5, 1, 2, 3. 1, 2, 3, 4, 5. And the point 1, 2, 1, 1, 2, like this. So that line goes here. And between these 2 points, I should have had 3 over negative 4. So from here, 1, 2, 3, it goes up to the left, negative 4. Or if I go the other direction, negative 3, positive 4. In either case, the vertical change negative 3 over 4 is the same as 3 over negative 4, because in both cases a negative divided by a positive is going to be a negative. Okay, let's give you guys a chance to try one real quick on your own. Let's use the points 2, 3, and 6, 0. So you might want to go ahead and pause it and try to find the slope between those 2 points. Okay, so thanks for pausing that and checking that out. I'm going to do this for you real quick. 3 take away 0 is 3. Let me move this up for you so you can see it. 3 take away 0 is 3. 2 minus 6, negative 4. That ended up being the same one. Didn't do that intentionally, but that's what we got. You can graph that and see that on there. Okay, guys, thanks for tuning in to check out this little video. If you are taking this class for IDLA, I need you to go ahead and email your teacher. Email him the phrase "Go Green," because that's my favorite college team, the Michigan State Spartans. So why don't you go ahead and email that to him if you are taking this for IDLA, and if not, thanks for checking in, and hopefully you learned something here.